viewers, and welcome back to the Self-Made Auto channel. You guys just never know what I'm going to drag through the door. Got a little bit of a hard time saying no, as you've probably learned at this point, looking at all the different things we work on and stuff. And mentioned before, it's all nuts and bolts. Well, let's kind of hope it's the case this time. We've got this GMC 4500 or a C4500, so a two-wheel drive 4500. It's got the Duramax Diesel in it. It was, well, what I was told, the guy who owns it came from another shop. The guy that, anytime I say it came from another shop, it's usually one of a couple, 2 or 3 places. But this guy sends me a lot of work. He buys these things and sells them, and buys all different kinds of stuff. So we do a lot of work for him, if it's a little beyond what he wants to handle. So told me take a look at this. He had it too, and he knows I don't really care to work on big trucks or medium duty trucks or diesels really so much as I do like working on gas engines and small vehicles. At any rate, he had this at the we'll call it the GM guy. He had it at GM, or a guy that works for GM, something like that. I don't really know. Supposedly he needed a special tool to fix whatever's wrong with it, and didn't have the tool. And at the dealership that he works at, they think that somebody stole this tool and whatever. So anyhow, it's our problem now. We got to see if we got the tool to fix this, whatever's wrong with it. But the symptom is I can't drive. It's got no plates on it. So what he tells me is that it skips. It has a misfire, a dead cylinder misfire. Supposedly the other guy told him that there's no power at the injector, and in order to test wire going to the injector or something like that, he needs this special box, something. I don't know. I don't work on diesels hardly at all, not anymore, not since I got away from that. Back when I worked in my dad's shop, I'm anti-diesel, just because it brings back bad memories. But I told him we could take a look at it. If indeed it is an electrical issue, I guess I don't care whether it's diesel, gas, or runs on bananas. I guess it doesn't matter. A wire's a wire, and hopefully in this case it's something like that. Whether it be a module, injector, or wire or whatever. But it's supposedly the engine light's not on, but it does skip. So it is OBD2. So we're gonna plug into it and see if we can do something. So the other thing I don't like about these medium duty trucks, big trucks and stuff, is typically these things are wired up messes. Oh, there it is. Because municipalities and stuff own them, and they have all their lights and all the stuff they need to make this truck work. And usually you look under the dash on these trucks, anything that's been outfitted, these things are a disaster. So we got for miles here. Oh, she's low mileage, 54,487. So we do have a working check engine light. I didn't even pay attention on the way in. Yeah, no, we just got the daytime running light indicator down there. So we'll leave the key on. So when you start it, it does sound a little bit rough. You can feel it shaking, and when I pulled it in, you pretty much had to have it right to the floor to even make it move. Could be because it was stone cold, but so we're gonna see if this thing will. I don't think the Verus supports medium duty applications. It is a 2005 according to the VIN number, so I'm gonna try to see if we can do auto ID here. See if it does pick it up. If not, assuming this is the same software and everything that the like a 1-ton runs on, maybe we'll just enter it in as a 3500 and see if we can get the right engine application and kind of take it from there. So put it in as an auto ID, we'll see what happens here. Sometimes they can surprise you. No, it does not support auto ID. Oh, but it read the VIN. So 5th VIN. So we got 245 is a 4, which is going to be our body, which it doesn't have. So we'll just pick rear wheel drive Sierra. How's that? 8th VIN. So 5 and 4 is 2. So it has that. So it's right engine, this LLY 6.6. We'll see if we can at least talk to this little guy. And it is an automatic. Let's just see if we can read data. Yeah, look at that. I think we can. That'll be kind of handy. Alright, so we can read data, whatever good it's worth, I guess. So I guess first thing first, let's see if we have codes. Let's go all codes. Well, there. We got a P1229 injector 3 output circuit. Well, that kind of makes sense with what what the customer is stating, and what he said that the guy at GM found. The history code, what do we got? Failed this ignition. Okay, so it's a current code. Malfunction indicator, service vehicle soon, message requests, no codes present. So that's interesting, that code doesn't turn the light on even though things running terrible. 1229. Okay, so that looks like the ticket. So I tell you what, being that we're right here, let's just go to our troubleshooter. I'm not really too familiar with these. Maybe this will give us some direction anyways. 1229. So code sets when computer detects command state and actual state of injector 3 control circuit do not match for less than 1 second. Okay, so it sounds like we've got a couple PIDs we could look at. Maybe command and actual state of the injector. So must have, okay. Engine light will illuminate on second consecutive failure. Well, that's weird that it's not on right now. You would think because he drove it here and I've turned it on to bring it in, you would have thought it'd been on. If only one fuel injector control code is set, open circuit or poor connection is most likely cause. If groups of 4 injector control circuits suspect short to ground, groups are 2, 3, 5, 8, 1, 4, 6, 7. More than 4 injector control circuit codes indicate short to voltage on fuel injector. And we're just dealing with one. So according to the troubleshooter here, perhaps we're just dealing with, poor connection, open circuit, something like that. Okay. I wonder, one thing I don't know is how these injectors work. Are they a standard 12-volt injector? Are they like the Fords that, what they call them, the Huey, the hydraulic electronic? I wonder if we can just go here, go to component test, see if we can see this thing VIN 2, right? See if we can see how this injector works, perhaps. Fuel injecting. I don't see probably under fuel systems. There we go, injector, component information. Okay, injectors are supplied power from the FICM. Fuel injection control module. Injectors are ground side control, so it's a ground side switch injector, 12-volt fed. Sequential fuel injectors are activated individually to maximize fuel control. Computer uses sensor inputs to calculate injector pulse width and sends commands to FICM to pulse width modulate. Oh, okay, so this is just like a car. This is like working on a minivan. So let's see what we have. Okay, so it looks like the FICM has 12 volts, and that feeds 1, 4, 6, and 7. Then we've got a command wire for 1, 4, 6, and 7. So then we have 12 volts going to 2, 3, 5, and 8, and then a command for 2. So this should be simple. What kind of special tool could we possibly need? Is that a test light? Yeah, and here's a 2-wire injector. Man, this is a gravy train. I shouldn't speak before we actually even look under the hood. I don't even know what this thing looks like. Oh man, popping the hood like this brings back too many bad memories. I hate working in a truck shop. Oh, the crap biscuit. What did they do with the engine? Oh my gosh, I thought it was going to be easy. So if you pop the hood on your C4500, you can see the air filter and the brake reservoir. Oh, and looks like the power steering coolant. And I think the engine's underneath here somewhere. Before we, looks like these, these fender liners, they pop right out so we can work on it. We better look up and see what side number 3's on. I don't know if we have a computer. Okay. So we've got this here. This looks like a GM ECM, so this is probably our engine computer. This little fender well comes out. What else? Can we identify anything else? I don't know if this box here is probably our FICM maybe. Does it say anything on it? EDU common rail. So yeah, that's probably our control module. Looks like it's got some fresh tape on it, so that's always good. Said no one ever. I don't see anything else. What else is taped up? Oh, look at this. This thing's been cut. You never know on these little guys, let me tell you. Got some wires out of the harness here. It's the thing with these diesels, you know, they can rub and vibrate and corrode. That sits pretty tight on that inner fender. I wonder if that's, you never know. Well, let's go figure out where number 3 is and then we'll go from there. So what we can do, it's kind of awkward. We should be able to find the cylinder bank layout here. Oh, you know what? Sometimes it's in the guided component test. We were just in fuel system, abbreviations. Maybe it'll be under injectors. No. Let's see. Let's go back to scanner. We'll keep going back here. Time savers maybe. Yeah, look at that. Cylinder bank layout. Okay, so passenger side 1357. Driver side 2468. So it looks like we're going to the passenger side. Pull these pins out of these inner fender. Maybe we got just that. Something like that, maybe. Oh my gosh. There. Wait. Well, that was easy. What if we put this thing on the lift? So things are still a little snug under here. So it appears that our injectors are right out here in the open, and we can see this is the number 3. All right, because I'm glad it's not the number 1, because it looks like that's up underneath this module here, which has to be our fuel module. It appears to have a fuel hose going to it. So let's be thankful that this is our number 3. It looks like somebody's already cut the wires on it and has, you know, maybe replaced the pigtail, or maybe there was a bad spot there or something. So that's kind of interesting. I guess the first thing we can do is we'll unplug number 3. I'm not sure how the plugs work on it, but we'll get it unplugged. And the camera's in the way, so I can't unplug it right now with my big meat nugget finger, I don't think. No, I'm gonna have to move you guys. I'll get in there and unplug it, and then we'll see if we have power. We'll see if we're missing a control side, power side. Something's got to be going funky here, and take it from there. I got our fancy test equipment. We're gonna use I want to front probe into that connector. I got the connector undone. I had to reach in there with a little pick, and she slid right off then. And we're going to use one of these front probes. I think these are for a GM here, so we're going to hook right into the front of that injector. It's that little kit I got from AES Wave. I think we just had it in a recent video with Pontiac. It's got a lot of different, here we go. It's got a lot of different banana jack type connectors. These were great for with the scope, little micro piercing probes, all kinds of stuff there. So we're going to use this. Accompanied with a test light. I'm just going to use my test light in there, and then we'll probe it in there and see what we got. So I'll try to do this with the camera down here. We'll get hooked up to a good ground. That's something. Let's see. What can we hook up to? Yeah, this wire's out of its loom too, so definitely somebody that's been around here, probably doing the hokey pokey. Alright, so there's a ground. Let me verify we got a good operating test light. This thing's all chewed up too. Not a good ground. There we go. Good ground. Okay, key's on right now. So I assume we're gonna have power on one of these. Of course, we can look back at our diagram, I guess. I'm always paranoid my test light's gonna quit. And it did. We gotta get a more consistent ground. I don't know. It's a problem in New York. What do we got? Give me something good. Give me something good, baby. That's probably just as crappy as what I had. Okay, now we got a good ground, I think. Let's see. Does that plug in there? It does. Wait, test like that. Come on. Okay, so I got nothing there on that one. I got nothing there on that one. So I got no light action on either one of those terminals. And I verified my test light does work. Okay, so now what we need to know is this, because the truck is not running. Yeah, I got no power on either. You guys probably see the back of my head. I got no power on either one of them. Okay, let me just make 110%. But that is true. I'm always worried about my test light going. Nothing there. Got a good test light. Alright, my test light ground is starting to make me upset here. We need to find something better. We got nothing, folks. Somebody's always probably like, this is why I use a multimeter. Multimeters. We can't go on, yeah, we can go on. Let's see, get hooked in that glow plug or something. There we go. Nothing. Nothing. Verify test light. Test light's bright. Okay. We have no power at that injector. Now, for the sake of testing, oh, never mind. I got it. Let's just unplug this one here. What's this, number 5? Isn't that how it was? Wasn't it 1357? Was it odd? Odd numbers in this bank. Let's just see, for grins and giggles, if we've got power here. Check our test light. That's good. Just see if one of these has power. That way we know what circuit we're chasing. Got no power there. Got no power there. Okay, so this must not be a key on, engine off, power supplied unit here. Yeah, our test light's good. I'm going to go ahead and start it up. Instead of chasing down a wire diagram, we'll start it up. We'll see if we have power. If we have power, then we'll take our diagnosis from there. I don't know if you guys can see that or not, but my test light is just flickering on the, looks like the pink with a white wire. Make sure I've got a good ground on my test light. And all we've got is a little bit of a flicker there. Check the other wire. The other wire, I've got nothing. My test light is good. What we're gonna do, we'll just go back to this injector. Oh, she doesn't like that. Let's just see how this acts when it's unplugged. I got nothing on that wire. Got a good test light, do we? Yeah, we got a good test light. We got nothing on that wire. Yeah, I got nothing on either one of those. It must kill the driver or something when we unplug it. Let's see if it goes back hot when we plug it in. Take my hand back into it. Nah, it doesn't. Okay, well that test is inconclusive because it appears that when we unplugged the number 5, obviously it killed that cylinder. You hear the change in the engine, but it also, you know, dropped the power to that cylinder. So I think it's important that we have a wiring diagram at this point so we can see what the heck we're doing. Let's just, for the heck of it, let's see if we generated any other codes by unplugging the number 1 injector or the number 3. Because that would be helpful. You know, is it still recognizing the circuit? You know, is there anything else going on? Of course, we're going to have a code for number 5 for sure. Yep, number 5, injector circuit problem. Injector position voltage group. Control circuit group number 2. Okay. I don't know if that's a result of unplugging number 5. You know, I guess possibly. So what we're going to do. I plugged number 5 back in and shut the car off, started it back up, and it, you know, it's back. We're back to where we started. So it obviously reset itself. So I'm thinking tests that we do from this point should probably be back probed or, you know, current ramp. You know, I'm thinking it's going to be the best option. So let's go look up a wiring diagram, see what we're dealing with. All right, so we're going to use this program here, the Mitchell medium duty program. It's going to go 05, no, what is this thing? It's a GMC in it. GMC, it's going to be a C4, just like the Corvette, baby. And this is the Isuzu 66 LLY. That's all of our options. We use this. We've got our wiring diagrams. Engine performance 66. All right, well, I'm going to dig through these. I want to find out where our power and whatnot is originating from for these injectors. And then we'll kick the camera back on when I get some direction here. Well, I got some wiring diagram here. There is our fuel injectors, and we can see we've got. Let me get a pen here. We've got this controls, or the this power side here feeds 4 injectors, and then we've got this power wire here that feeds the other 4. And this is what we're looking at, number 3. So it's the red and white wire that we're looking at that should have power, and that comes up, and it goes up to our fuel injection control module. That's where our power is originated. I assume there's no sense in going here and testing it because we know number 5 injector works. It can't work without power. So what we need to do, I don't know if back probing it would be the best thing. That we ought to take just a couple preliminary injector checks. Obviously there's going to be some kind of measurable resistance value of this injector. We need to check that. If we can't find the value, we'll just compare it to a known good. So that'll be a piece of cake. And once we have that, we can try you know, back probing it and checking it for power, and we can compare the test results from that to, you know, perhaps number 5, being that it's right there and we can work on it. And then if we find that we have power, then obviously we have to check this control side, this number 3 control, which is the white with light blue wire, you know, which also comes up to the control module, and see what's going on there. Come right back over to the Varus. Got it over here. We'll go back to fuel system and the injectors, and then we will do resistance check. Resistance should be between, oh wow, 0.2 and 0.4. These must be some pretty high amperage draws here. That's almost a, you know, short circuit, so really, really low resistance. Any injectors with resistance that varies greatly from the other. Okay. No other information. Okay, so really, really low resistance. I wonder what the current, it might be, it probably has some kind of current limiting device. Yeah, 22 amps. Voltage supplied is 50 volts. That's weird. Why did it tell us Didn't it say these are 12-volt injectors? Didn't we read that? Well, it says ignition plus. I guess it doesn't specify 12 volts. From FICM. Ground side controlled. Huh. Ignition positive. I mean, to me, that would mean these things are 12 volts. That's kind of weird. Voltage supply is up to 50 volts and over 22 amps. Do not make contact with fuel injector harness, ECM, or fuel injectors with ignition on or run position. 1,000-volt gloves. Wow. Warning, warning. Holy crap, biscuit. Extreme caution. 24 volt AC. What? This is talking AC. This is kind of bizarre. Thousands of PSI, yeah, we know that. This is stating as 24 volts. Let's see. Extreme caution work surge greater than 40 volts DC or 24 volts AC. Okay, maybe that's just like a general warning. Electric shock can occur. Wow. Ain't that something? I could have got slit on this thing. Just because, you know, is it the flyback voltage that's 50 volts? I don't know. I would think that we're talking 12 volts here, people. Good thing we didn't blow up, huh? So what we're going to do, we're just going to keep on trucking. And we're going to take, there's probably these little yellow ones here. We're going to hook up, I'm going to hook one of these in each side of the injector. We're just going to take and check the resistance on that injector, see where that's at. Just kind of start gathering some information we know. I'm a little confused on the, you know, the high voltage, applied voltage. You know, kind of got a little misinformation there perhaps. Or maybe I'm misunderstanding it. You know, I don't know if when that field collapses, when that injector fires, you know, the voltage is sent back. You know, perhaps, and I don't know. But we're going to proceed with caution at this point. So I'm hooked in under there to the number 3 injector. It looks like that one is 0.1 ohm. So I'm plugged back into that number 5 injector back there. And that too is also 0.1 ohm. So we can only assume that's a good value. I think the according to the Veris, it was what, 0.2 to 0.4, but we know that number 5 is a known good, so we'll stick with that. So being that we're right here, I took the, I got the current clamp hooked back there on the number 5 on the power feed to that, because it appears, you know, obviously we're gonna have to do all our testing plugged in. I think that's where you're gonna get, you know, if you're gonna get smoked by something, it's gonna be when it's plugged in. I don't believe these actually send 50 volts to, you know, to these injectors. I could be way off on that, but I think it's probably the, you know, the release of energy when it, you know, when it fires is what I would assume. I could be wrong. This isn't electronics 101, but so I've got it hooked up to the Veris, or yeah, the Veris, the Vantage here. So let's take and start this up and just get a look, perhaps at a good current ramp, so we can see what we've got here. So I held this waveform for us. You can see our peak voltage there is about 1.46, so about 1.5 volts. So every 1 volt is 10 amps, so we're about 15 amps here. And it looks like it must be some kind of multi-spark system. It, you know, kind of double taps that injector there, 2 different peak times. And obviously, you know, we don't see like a, you know, like that buildup like we would on a gas injector, or you know, like a coil. So this, if we seen this on a regular injector, we'd be like, oh, the injector is shorted, but this thing's only got 1 ohm resistance, so that's what we expect to see, is just that, you know, that huge amperage spike, you know, holds it, then it releases it, fires, amperage spike, you know, holds it, fires. How much time is between each one of those events from firing? Oops, swap cursors. I don't use this part of this tool a lot. No. What's our time? 2.25 milliseconds between the off time of each injector. So we can see that as just kind of a little bit of a fact. So what we can do now, we can move our current clamp. I don't suspect we're going to see anything on this one. So that's number 3. That's where our current clamp is, but being that injector doesn't appear to be working. Let's see, we got to get this back to working again. So we'll go to run. Okay, we're back live. We'll go ahead and start it up. I don't suspect we're going to see anything, but you never know. I didn't think we'd see anything. We don't. Just to make sure that we're good connection here. That's our number 5. We're definitely dead. This still leaves us with a couple options. You know, we're still kind of back to where we started. You know, power side or control side, you know, what are we missing? We're gonna have to come up with a little different testing method, because obviously key on engine off, we can't check for power at the connectors, because we noticed that didn't work. I wonder if, boy, you know, the first thing I want to do is I want to clear these codes. I've seen codes generate on, you know, different types of coils, you know, whether it's ignition coil or it's an injector. That driver circuit has a problem, even a momentary problem, shuts it right down, that's it. Usually they come back with key cycles, you know, like we seen with the number 5. You know, we unplugged it, ran crappy, we plugged it back in, it didn't work. We actually had to cycle the key. So, but just to be on the safe side, let's just clear the codes. We know what code's in it. See if it, you know, obviously see if it generates right back. If it does, then we'll kind of take it from there. I got to kind of collect some thoughts. You have to kind of excuse me for my ignorance on these. I don't work on this stuff, so we're just kind of, you know, learning as we go. But I think we've got some good direction ahead, anyways. Yeah, I just turned the key on. So we'll poke back out here. We'll go to our scanner. We'll clear the code. Excuse me, let's just, I got a cough in here, smoke another one. All right, so we got no codes there. Let me fire it up. All right, it sounds like it's skipping still, maybe. Yeah, okay, there we go. All right, so this is the next plan of attack that I came up with. I've got a back probe in the control side of the number 3, and what we'll do is we'll hook it to our meter. I've got the other end of the meter hooked to a power source. So if that control side is working when it's plugged in, we should be able to see it on our Vantage here. And I think this will give us some direction. You know, what are we looking for? Are we looking for control side problem, or are we looking for power side problem? So it appears, looking at this, that our control side is good. I guess we'd have to compare it to number 5, but you know, this looks pretty dang similar to the, you know, the current that we were getting on the number 5 there. So that's some good direction there. I think what we can do too is we can back probe the power side. Of course, we can compare this to the number 5. I don't think we have to. Let's back probe the power side on this injector and see if we have anything going on there. So this is pretty fun, right? Working on a big truck, like a trucker. Yeah, so we'll come right under here. I hope this is making sense. I've rationalized it in my mind, I guess. Get this connector undone here. This connector's a pain. Okay, so I'm gonna probe into the power side of number 3 here. So back probe into that. Plug that in. We'll switch our test leads. Got my test lead here. To that. We gotta try to find a known good ground here. Where we had our test lead before. These clamps are a little stronger. So we'll get that in there. So key on engine off right now, we got 10.65 volts. I don't know if that's a real voltage. Oops. You know what I'm saying? That could be just straight voltage. I guess we can figure that out. Grab our load pro here. What do we want to do with this? We want to hook this to a, kind of doing all this, holding the camera. So we'll hook this to a ground. See if our test light works. It does not. Whoa. Let's see. Alright, I gotta sit you guys down for a minute. Okay, so there's that. Our voltage is going down. Actually, it's 7. It's actually counting down 7 something. I might just touch it with a test light, and of course it goes right to 0. So that's just a ghost voltage. We proved it using the load pro here. 250 milliamps. Not get a good ground to save my life here. There, geez. Okay, so we got a good ground. Let's do this again. So all we're going to do is apply a little load to this. You can see we've just got this straight ghost voltage, and it goes down to. We get a good connection on it here. It would go down to 0.00. So that voltage is nothing to be concerned about. So we'll get this set up on a waveform. See if this voltage comes back when we start it, and then what we can do. Let's assume it doesn't. What we can do is make sure this is a valid test. We'll go on number 5, which it should be. And this portion of it, this primary voltage, it should look like, I'm thinking it's going to look like, you know, that of a primary voltage, kind of like a spark plug a little bit. You know, we're going to see that firing event of this coil, and, you know, we're going to see the, you know, the voltage spike up. I'm assuming we're going to see something like that. So we're going to do, let me fire this pig up. Alright, so this is kind of bizarre. It looks like we have our event. Oops. Let me just get this. Probably should be using the Varus for this. We actually may use the Varus. Kind of what I was expecting to see. We're on to number 3. Kind of half wondering if this thing still has a code in it. I mean, hard to tell now whether the thing's skipping or not. Go here to codes. Just for the heck of it, let's just make sure it's not a stored code here. Okay, so we still have a problem going on here. That's crazy. So I just gotta stop and think for a minute. The you know, the power side test on that injector, I guess it doesn't matter if we're in 1 or 5 or, you know, what one we're in, because, you know, just looking at the wiring diagram, all the powers are tied together, at least on 4 of the injectors. So, you know, this would be, you know, just like doing, you know, current ramp testing or anything at a fuse box like on a gas engine. We're gonna see each injector. We're going to see 4 of those injector on the power side, Yeah, so we still have we don't have any current. Okay, so we got no current there, but we had the control side. You know, when we were using the Vantage there, we hooked to power and we hooked to the control side. You know, we could see it, you know, pulsing that ground. This is weird. Just trying to do some thinking. I think a test I want to run, I guess I'm still indecisive as to whether or not we have a problem with the control side or the power side. What I think we can do, we'll grab the Varus, we'll plug that into it. I think what I want to do, you know, to make sure that we're definitely missing this event. Okay, so the injector seems fine. That's at, you know, 0.1 ohm, so that's good. What I think we can do is I guess to verify the power at, you know, the key-on running power, because the thing's got to be running to have power at the injector on number 3, which is our suspect injector. I think what we need to do is back probe the power on a number 3. Okay, so that's going to give us our, you know, that's going to give us our waveform, and like I mentioned, it appears it is just like in the literature that's hooked to the number 8 cylinder, the number 5, the number 3, and the 2. So 2, 3, 5, and 8, I believe, according to this wiring diagram, are on the same power feed. So, so if we back probe that, we should see our signal there. And then I think what we need to do for a control, so typically we would use like a cylinder identification, you know, but we're not going to grab a hold of a spark plug wire on this thing. So we'll use a current ramp on another channel well, we'll just go right to the number 5. Well, look at that waveform. I think, you know, when we do that, we should see our missing cylinder. We should, you know, I'm assuming that we will. I don't know what this is going to tell us. I think it'll tell us that, you know, perhaps our power feed to that injector, assuming we see, you know, a good waveform, is good, or at least the wire integrity right up to that injector is good. I have to think about it, man. This is that's almost 7 o'clock. I need to take a break, get something in my stomach here, and do some thinking. But we can do that test real quick and see what we got. All right, so here's how I have us hooked up. We're on the number 3 injector. We're back probed into the power side of it. And on the number 5 there, I threw a current clamp on. I've got it set up on a dual trace on the lab scope. So let's capture this waveform. Go ahead and start it up here. All right, so here, channel 2 is our voltage, and then this must be, so this kind of proves, you know, proof concept. We knew this was going to happen like this. This is our current ramp for number 5 down here on the yellow trace. Okay, so this is our current ramp right here. Even though I'm probed into the number 1 cylinder, or the number 3, we're seeing the firing event for the number 5 right here, because all the powers share the same. So technically, we should see 4 of these events right in a row. So let's just stop that. Let's record it. Stop it. Let me go shut it off. Shut it off before we choke to death in here. So let's back this out a little. And see, we can see right now that we're missing an event, which we knew. So here's cylinder number 5. Here's our missing cylinder, then, you know, whatever other cylinders were on here. We should see one more firing event here. So we're not, I don't know if we're any further ahead than we were, but we can obviously see that event is not happening, and that could be on the account of the, you know, the control side or the power side. Got to give this a little more thought here. I just thought it was kind of a neat waveform to capture. But we can see the firing event there on number 5. So So I just want to take a second and look at this waveform, and I want to try to understand it, because we can see that our injector is running at like, I don't know, 17 volts, something like that, and there's no current being passed through it. So it's just, you know, this could be any voltage, any kind of measurable voltage with no current. And then all of a sudden we have current draw of, oh, you know, 15 amps or so, or even higher. It kind of spikes up here almost 20 amps. But then look what our voltage does too. It goes up to like 48 volts ish probably, you know, just very briefly. And then it starts to decline, you know, then we've got this downward slope from, you know, around 9 volts down to 5 as the current is being applied, or as there's current flow. Current stops, pops back up to our baseline voltage of 17 or whatever it is, and then repeats that process for like this twin firing sequence, or, you know, I don't really know what to call it. I'm not very familiar with these, I don't know the terminology. But what's weird is, you know, if we had, let's say, 17 volts, 18 volts, whatever this number here is being applied, and then all of a sudden our driver turned on, so that's what I can assume at this point here, you know, when our current goes up, that's when our control side is commanded on. You'd expect the voltage to drop. But in our case, the voltage, you know, spikes really high. So must be that high voltage must be being applied from the control module at the same time the current is being applied, if that makes sense. So, you know, must be the power side is turned on, amped up, whatever you want to call it, the same time that the control side is also being commanded on. And then must be it cuts them at the same time, you know, that coil saturates, you know, it pulls the injector open. You know, you can see the voltage decreases, releases it, injector closes, and then it opens the injector again. So I just made that observation. I don't know, I'm just still trying to think here a little bit. So just for the sake of testing, I went ahead and I moved our back probe in the number 3 to the control side. Now I've got the current clamp still where it is back there in the number 5. What I suspect that we will see is the same thing we saw when it was on the power side, because that injector is not, you know, not functioning. I assume we're going to see the voltage being passed through the, you know, the 1 ohm resistance of the, or the 0.1 ohm resistance of the coil, and I think we're just going to see the same waveform, to be honest with you. So we can take a quick peek at that. Just trying to get a little bit of direction here, to be honest with you. So that's the same thing we were seeing. That's kind of what I expected, to be honest with you. Well, I don't really know. I think here. I guess I haven't learned anything other than the fact that number 3 is still not contributing. You know, we can see it missing. We see the current ramp missing. I don't see any real anomaly there, and in fact, it's missing. I hope I'm not way off in my thinking that, you know, the voltage being applied to the injector at the same time the current's turned on. That seems plausible, I guess. I'm not, you know, super savvy in this and electrical theory and, you know, internal components and, you know, things like that. But looking at the waveform, it kind of appears that way. So being that we probe the control side and we're just seeing, you know, the voltage from the number 3 coming through that coil, if the FICM sends power the same time it sends, you know, a control signal to a given injector, you know, we could still have both problems here on number 3. You know, is it not firing the number 3, you know, sending its 50 volts or whatever that voltage is to it? Is it not sending that? Or is it, you know, is it also not sending the control to it? you know, also. So that I don't know, and we can't really test the control with it plugged in because we're gonna see this voltage, you know, coming from the other injectors right through that coil. I don't know if I don't know. I guess I don't know. Unplugging it, I think we already had it unplugged when we were using the little Vantage and checking the control side of it. I don't know if that's a valid test though, you know what I'm saying? I have to give it some more thought. So I think what we can do, I want to grab the wire diagram. The control module, this FICM, as they call it, it evidently receives its signal to fire the injectors from the ECM, then it processes that data and gives us our smoke. It has itself, let's see if I can find it here, injector control number 3, injector control number 3. So that comes from the engine computer. And then there's these other wires that go to the number 3 injector. And on here they call them injector control also. So injector 3 control. So one goes to our injectors. The other one comes from the ECM. So what if this wasn't receiving its signal to, you know, spray diesel fuel? So why don't we just go right to the FICM and see what kind of signal that is? I don't know if it's, you know, power side switch, ground side. I don't know what kind of signal it sends, but I think we can figure it out. We can always compare it to a known good too. This FICM is right up there, and looks like connector C1. Yeah, there's 2 connectors, C1 and C2. So it looks like a couple connectors there. So why don't we go to that next and see what we can figure out. All right, so what I did is I took and unplugged the lower connector on that FICM. I used a wire diagram here. Well, it's on the ground now. And I found the control wire for number 3 and number 5, just because that's one we've been using. We know that cylinder's good and doesn't have any issues there. So what we'll do is we'll get these plugged in. I'll get these set up, and we'll see what that signal looks like. Hopefully. We'll get our scope set up here. Kind of show you where we're at here. See, we just fired this up. So channel 1, our yellow channel here, is the number 3 control from the PCM to the FICM. So this is what the FICM is seeing. So it looks like we're going from 0 to 5 volts. So it must be a pull-up style, 5 volt input. And the green trace here is number 5 injector. We're gonna have to change our time basis here. Actually here we can change these down to 10 volts now that we know what our scaling is. Get a little better definition. We'll just check my ground here. Try to make sure I had a good ground. Let me turn these filters off here. Alright, well anyhow, we're going to have to change our time basis if we want to see that other firing event. Oh yeah, I guess it's not going to be in the screen if we do that, right? Slow it down here a little more. There we go. Okay. Oh, you guys got a glare there. Alright, so there's both of our firing events. Here's number 1, or I'm sorry, number 3, and that's number 5. And they look the same, so it's going from 0 to almost 5 volts. This is going from 0. Get it up here on the grid. That's just a smidge over 5 volts. Right? Yes, that's 0. Yeah, I don't know if that's really anything to worry about. You know, the control side being drawn a little bit higher, I don't know. But we can see we've got both signals for sure. I think that kind of eliminates our ECM as being a culprit, being that it appears to be sending the signal to this control module, this fuel injection control module for the diesel injectors. I guess we just have to come up with a definitive way to, you know, is that thing just not processing the data, or, you know, do we have a, you know, a wire, you know, there's a control wire open circuited down to the injector. I don't believe it's the power side wire, because we can see when we were back probed in our injector, we could see the firing events of the other injectors, you know, through it. You know, I think that kind of leaves us down to the control side here. Come up with a definitive way to test that, and I think we can kind of make a call. Now, just looking at the wire diagram, I think the easiest way to tell perhaps if our wire is broken on the control side to the injector, to injector number 3, is let's test, because we've seen our voltage waveform at the injector, on the control side. You know, we've seen that, you know, we've seen it on the power side and we've seen it on the control side for number 3, even though, you know, we didn't see a firing event for number 3. So why don't we just take and where the number 3 control here comes out of this FICM, it comes out of the other connector, it comes out of connector C1, so it's going to be the bigger wires. Why don't we just back probe that? If we see our, you know, all of our other injectors firing event, you know, coming back down that line, then we know our wire's good, and we know at that point that this control module does not have the ability to control. And at that point, I think we could say that the control module is toast, because there would be no other sense in checking the powers and grounds going to it, because everything else works. We've lost one circuit. So I think that'd be the easiest test to do. We can check right here. Now, if we check that and we're not getting any voltage up there, we're not seeing the other, you know, the big voltage, the 50-volt voltage spikes, you know, from the other cylinders, then we know we got a broken wire. So that's a pretty quick test I think we can do. Let's just see where we're at. So that's the control module there. I just pulled the back cover off the back of that plug. I'm in the white, it looks like a green, but it's actually white with light blue. So that should be our number 3 control side. All right, and then I'll set up the scope. Of course, we only need one trace now. We'll set that up on that 50-volt scale. We'll see what that looks like. And I gotta assume, if we're seeing, I hope I'm not wrong on this, but if we're seeing our, you know, our voltage feedback from the other injectors, then that means our wiring's good, and we have no, you know, the FICM there is not controlling the number 3 injector. So you can see what's going on here. Well, there it is. That's the same pattern we were seeing before. And that is at the control module. Of course, this is not cylinder number 3, remember. This is, well, here, let's see. We're still going to see the missing event. Sorry for the shaky camera. It's just easier to do it this way. Let's go record and then stop. We'll back it out. Now we should still see. You see how we're still missing? That's still, oops. Is that still apparent that we're still missing, you know, an event that should be right here? I think this control module is bad. Well, it's starting to look to me like this FICM is bad. It appears to be receiving its command to fire from the ECM. Of course, that was like a smidge higher on the voltage than, you know, the number 5. You know, it was like, what, 5 volts instead of, you know, 4.8 or something like that. you know, is that a clue? I don't know. I kind of more suspect I'd have a missing signal. And now we've got, you know, we can see the parade of the other injectors. I keep on calling them coils. Stupid diesel smoke's getting to my brain. We can see the parade of those up on the control side. So, you know, that tells me the wire's intact all the way up to the FICM. The only thing, you know, I wonder the, you know, this FICM must apply high voltage, you know, at the same time it provides, you know, making it fire, you know, the ground side. It must, you know, turn on the ground side, the control side, and then increase the voltage, you know, which ultimately gives us this big amperage boost. And then, you know, you can see that being drawn down. It's kind of neat, but I guess shame on me for assuming it was, you know, just this 12 volt style injector. You know, like I say, I just read on the, you know, on the Veris there, like, oh yeah, it's, you know, ignition voltage supplied and ground side controlled. So, you know, I'm in there all willy-nilly in my Tesla. I come to find out this thing can fry your brain. There's not even a big warning label on there saying don't touch this, but live and learn. That's how I got my education. So here we are. I guess one last thing we could do before I make this call on this thing is we can take and unplug it, and then we should have our resistance reading of our injector right up here at the FICM, the, you know, 0.1 ohms. You know, of course we're gonna have some wire and some connections in the way, so maybe, you know, smidge more resistance than that, but I would expect something, you know, thereabouts. So why don't we do that, and then we'll call it time of death. I went and unplugged it, and I used those little terminal probes there out of that we got from AS Wave there, and I've got it probed in there to the power feed to the number 3 injector and the number 3 injector control side. I've got our little clamps hooked on there, and we are at 0.3 ohms, kind of toggling down there, 0.3, 0.1. I guess to prove that we're hooked to it, I can go under there and unplug it, and we'll see this reading should go to infinity. All right, I got to own up to a mistake, but not a big one. Hang on here. Whoa. So I was plugged into, when we just did our last voltage test, well, anyhow, I unplugged the injector and the resistance reading stayed the same, so I'm like, panic. So I started double checking my wires, and how I said before, I was in the white with you know, light green. Well, that's actually a real wire color. The white with the light blue that we were supposed to be in is actually on the bottom side of that harness. It's the pin below it. So needless to say, I went through and redid our voltage tests and got the same exact results. Wow. I'm kind of glad I did the, you know, this ohm check. But needless to say, when I was ohm checking the right wires, you know, I still had the 0.3 ohms resistance unplugged in. Then I went to infinity and beyond. And then, like I said, I redid the voltage check, so we're still good. Still gonna make the same call, but had me a little nervous there for a minute. So I guess at this point, we're gonna leave it at that. I mean, unless I'm, you know, blatantly missing something because of lack of knowledge of the system I'm working on, it appears that that control module, the fuel injection control module, just isn't controlling. You know, here's our harness is good. You know, it's not stepping up the voltage, nor is it turning on the control side of it. I guess, well, we wouldn't really know that because we don't have any, you know, applied voltage to it. See, looking at that waveform on that current ramp, if it was turning on the control side, you would think that, let me show you. All right, coming in the office here where we can see what the heck we're doing. I guess you guys can see that. Okay, so this is our waveform we captured. You know what, just real quick, I want to save this before I had to go through and recapture this because I didn't save it last time. We'll just, yeah, this label, I'll remember what it is. I'll come back and fix that later. So we gotta do all that. Okay. So it's going to be our current ramp, our number 5, and then our control side. We're probed in the control side of the number 3. Oops, let's pick out an event here. So what I guess my thought is, I guess where I was going with my train of thought is, if the control side of our injector was still working, so we can see we have this baseline voltage of whatever. So what is that voltage? Let's see here. It's 18.7 volts, 1819 volts. Okay. So we have this 1819 volts here in between firing events. And this is number 5 firing. I would think if the control wire on number 3 injector was turning on, even the control side, it would take this and pull this right down. It would take our 1819 volts here and it'd drop right down to 0. We'd have like a little, depending on how much current this could carry, which I assume this is some kind of bias voltage or something on there to detect, you know, whatever it detects, maybe open circuits, stuff like that. You know, so I assume this is some kind of bias voltage, ghost voltage, something, because it's obvious to me, or, you know, I may be way wrong on this, but I think what it looks like is that, you know, at the moment this coil is commanded to fire, so right there at that exact time, you know, our current draws up, the voltage is applied to that injector. It's the only thing to me that kind of makes sense. And you know, we see a big spike in current, we see a big spike in voltage. You know, then it's kind of, you know, holding it open, it appears, for its cycle. You know, I assume the pintle opens at this point and the injection process begins, and then, you know, it's closed and then, you know, reintroduced again here just moments later, you know, a few milliseconds later. Let's see here. So start to start, we're looking at 2.19 milliseconds. But I hope what I'm saying makes sense. You know, just rambling, babbling a bunch of crap here, but like I say, if that control side worked, you know, independent of the power turning on, I would assume this waveform would drop right to 0. You know, we'd see a big glitch here, and then we may know that, okay, you know, our power wire's broke. But I'm pretty sure we've got a bad control module. That's my final answer. I guess one more observation. Hope this shows up good on that screen. I was just sitting here, I was getting ready to go home. So when it does its initial peak here, you know, as this current ramp builds up, and you know, this pintle, the injector goes open. Let's see, we're carrying a steady current, but it appears that, you know, these oscillations here, you know, is the FICM controlling the voltage? You know, because that's dropping down to 0 volts and then back up to 10. Obviously, still carrying current, you know, across this path. Is it, you know, duty cycle that? And you know, just kind of something I observed there before it, you know, finally cuts it back to, you know, essentially turning it off, no current flow, then back to this bias voltage. So I didn't know if everybody saw that. I think before, when I first captured these waveforms, I may have had the filter turned on, so we might not have seen that level of detail right there. So just something I thought was kind of neat and worthy of looking at. I think that's it. I just called the guy who owns it and told him. So I think he says he perhaps has another Duramax on there with this LLY engine in it. This is what they refer to it, so that must be the RPO code of this engine. And you know, maybe we can take the FICM off of that and, you know, swap it on here just for verification, and then, you know, then I'll have a truck with no FICM. But yeah, I think I'm pretty happy with my test results, and it appears that the FICM is receiving its signal there to fire, and it's just not doing anything with it. And you know, we appear that we've got a continuous loop all the way down through our injector, and our injector's good, so I think we made the right call. So we'll find out when we get a new one, whether I'm right or wrong. If I'm wrong, then I'm gonna have to do a lot of research, but I'm a little ashamed that I didn't didn't do a little digging on this injector before I went in and did the hokey pokey, to be honest with you. I don't know if it could have got stupid or not, but it didn't. So, another day. Made it another day, folks. So, check us out on Facebook and Google Plus and all that business, and subscribe to our channel if you haven't done that and you want to stay up to date with all of our repair videos we roll out here each and every day, and you know, well, a couple times a week anyways. And just remember, viewers, if I can do it, you can do it. Thanks for watching.